everyone and welcome back to School-O-Sophy. So in my previous video I spoke about active transport and today I'm going to speak about variation, which is a topic in maths. And in variation I'm going to speak about direct variation today, and in my next video I will speak about inverse variation. So let's start. Direct variation. Direct variation means when one quantity increases, the other also increases. Like let's take this example, y is equal to 2x. If we increase the value of x, the value of y will also increase. This is a table to show its results. For example, when x is suppose 1, then y's value is 2. But when x's value is 6, then y's value is 12. This means that when x increases, y also increases. Let's take another example. Y is equal to 3x. So, when x is 1, y is 3. And when we increase the value of x to 6, the value of y also increases to 18. So, y is directly proportional to x. This is known as direct variation and it is written as this. This sign means directly proportional to x. Therefore, we can either write y is directly proportional to x or x is directly proportional to y. Now, the graph for such kind of variations, that is direct variation, is this way. When our x quantity is directly proportional to the y quantity, it is a straight line. I'm sorry, this part is not that straight, but it is a straight line that passes through the origin. So, this is our x-axis and this is our y-axis. So, when we increase the value of x, the value of y also increases. This is known as direct variation. When we write y is directly proportional to x, we can also write y is equal to kx. This k is the constant. That is, in a straight line graph, it will be the gradient. The value of this k will always remain the same even if the values of x and y change. Therefore, this k is known as the constant of proportionality or the constant of variation. This k can be helpful when we solve sums on direct variation. Let's see how to solve sums on direct variation. So the first sum, y is directly proportional to x. If y is 6 when x is 2, find k. That is, first we need to find out the constant of proportionality, value of y when x is equal to 9 and value of x when y is equal to 30. So to solve the first one, we will use the equation y is equal to kx. Now we know y is 6 when x is 2. So 6 is equal to k into 2. K will be equal to 6 divided by 2, which means k is equal to 3. We have the constant of proportionality or the k, and with the help of this k we can solve these two questions. So, even if they do not ask you to first find out the constant of proportionality, it will be helpful if you first find the value of k, because that will make it easier for you to solve the next sums. So, let's take the second one. Value of y when x is equal to 9. We know y is equal to kx because y is directly proportional to x. So, y will be equal to 3x. They have given us the value of x, that is 9. So, y is equal to 3 into 9, which is 27. Y is equal to 27 when x is equal to 9. Let's take the third one. Again, we use the formula y is equal to kx. So, we have the value of y, which is 30, and we need to find out the value of x. So, 30 is equal to 3x. X will be equal to 30 divided by 3. Therefore, x is equal to 10. When x is equal to 10, y is equal to 30. So, this is how you solve basic sums on direct variation when y is directly proportional to x. This is another example of direct variation which can be used in daily lives. So, the question is, if a stone is dropped off the edge of a cliff, the height, that is h meters, of the cliff is proportional to the square of the time t seconds taken for the stone to reach the ground. It takes 5 seconds to reach the ground from a height of 125 meters. So first we need to write down the relationship between h and t. Then we need to find h when t is 3 seconds and t when h is 180 meters. So the very first important thing is we need to know what is proportional to what. So the height is proportional to the square of the time. Now this is very important. We have always done y is proportional to x. So here it will be h is proportional to t. But the case here is this is the square of the time and not only t. So h will be proportional to t square. Nothing changes, just h will be proportional to t square rather than h being proportional to t. So to write down the relationship between h and t, h is directly proportional to t square, which is equal to h is equal to k t square. So the k remains the constant, that is constant of proportionality, and h is directly proportional with t square. Then we need to find h when t is 3 seconds. But before solving this, we need to find out the value of k. Here they have given us that it takes 5 seconds from a height of 125 meters. So when h is 125, k into the square of the time, that is 5 square. That is k is equal to 125 upon 25. K is equal to 5. So the constant of proportionality will be equal to 5. Then we can solve this. So h is equal to kt square. H is equal to 5 into 3 square, that is 5 into 9, which is nothing but 45 meters. So the height of 45 meters, when the stone is dropped from the height of 45 meters, it takes 3 seconds to reach the ground. Then to find t when h is 180 meters, we will again use the same formula. H is equal to kt square. So 180 is equal to 5 into t square. T square is equal to 36. But here they only need t, not t square. So we will balance this on both the sides. T will be equal to square root of 36. T will be equal to 6 seconds. So when dropped from a height of 180 meters, the stone takes 6 seconds to reach the ground. So this is how you can use this proportional method to find out the answers of various questions. That's it for this video. I hope you understood. If you have any questions, please put it down in the comments. And if you want me to post a video on any topic, please put it down in the comments. So bye-bye.